In this video, I'm going over now power rule for calculating derivatives. So what we've done is like that background of with the instantaneous rate of change. And so now here, focusing on our limit. So now we're going to get into our different rules when calculating derivatives. So today we're going to focus on the power rule. Now keep in mind, remember our different notation when asked to calculate a derivative. So like here, this is one notation for our derivative. Another notation, if you recall, is the F with the apostrophe. So that's another notation. You'll also see another notation which shows asking for our derivative. So here's the power rule. The power rule states that if when you have a base being raised to an exponent, so like let's say our exponent is n, that n then becomes the coefficient, and then you need to subtract 1 from the original exponent. So just to fill in this table, here's what this means. So see how we have f of x is equal to x squared. Our exponent is 2, so the derivative of x squared, in order to calculate instantaneous slope of this function, you would bring down, and this becomes our coefficient. So now I have 2x. Then subtract 1. Well, 2 minus 1 is just 1. So that is the derivative. So if we wanted to know at the x value of 5, what is the instantaneous rate of change? Well, that is 10. 2 times 5. So again, there's your derivative, 2x. So here, again, the exponent is 3. So the derivative of x cubed to calculate instantaneous slope at any given x value. We bring down our exponent of 3. So now 3 is the coefficient. Then subtract 1. 3 minus 1 is 2. So the derivative of x to the third is 3x squared. So again, exponent of 4, so x to the fourth, bring down as your coefficient 4x minus 1. So now it's 4x to the third. So what do you think x to the fifth is going to be? 5x to the fourth. That is the derivative of x to the fifth. Bring down as your coefficient and subtract 1 from your exponent. So this is power rule for calculating derivative when you have a power. So here, again, we already just did these. We're calculating the derivative. So x to the 37th, that means our derivative would now be 37x to the 36. 37 times x to the 36. Now, notice in 1b how we have a fraction. So whenever we have a fraction, rewrite it. So remember, whenever we had x here, and x technically does have a power. It has an exponent of 1. But when it's in the denominator, this is the same as rewriting it as x to the negative 1. If you recall, negative exponents means reciprocate the base, so it becomes 1 over x. Now that we've rewritten in exponential form, x to the negative 1, now we can apply the power rule. Bring down now as a coefficient. So this is negative 1 times x. But then remember, right, we do still need to subtract 1. So now the exponent is negative 1 minus 1, which is negative 2. So now let's rewrite this. I've got negative 1, or making my fraction, so negative 1 over x to the second power. Because again, x, our base, is being raised to a negative exponent. That is the derivative. So then here, if I've got y is equal to radical x, so that means, again, let's rewrite it. Well, remember, this is x to the first power inside of a square root. So this is x to the 1/2 power. Now we're going to go through and apply our new coefficient for our derivative. So remember, this is our derivative, is 1/2 x. Then again, remember, subtract 1. Now this is 1/2 minus 2/2. 1/2 minus 1. Remember, when subtracting, right, denominators have to be the same. So our new exponent is negative 1/2. Now let's rewrite it. We have here our derivative of our function is in our numerator is 1/2. Then x again has a negative exponent. So x to the 1/2. Or again, rewrite it as 1/2 radical x. So then here, notice now we have still another radical, but one of those cases. So again, in the denominator, so when we rewrite this, this is going to be x to the negative 3/4, right? Remember, raised to the exponent. So now here we go. Let's rewrite it. Bring down as the coefficient. So this is negative 3/4. So our derivative is negative 3/4 x. Then again, subtract 1. Now this one tricky. This is negative 3/4 minus 1, which is 4/4. This gives us negative 7/4. So now let's write this as our final derivative. Here we go. We have negative 3/4. So negative 3/4 and x to the 7/4, because again, base being raised to a negative exponent, which again here is negative 3/4. Then inside of, remember this is x to the 7th, right? Go straight up to your exponent, and then our 4th root. So here we go, and that's your derivative. So go ahead, pause the video, and try these 3 on your own. And here we go. So for the first one, you should have just brought down your exponent. So your derivative is 9x to the 8th. Now here you had to rewrite this. So this is the same as x to the negative 4th. Now when you start writing your derivative here of this function, you should have negative 4 times x to the negative 5. Subtracting 1, that's negative 5. So now when you rewrite this, your derivative, whoops, sorry about that, your derivative is negative 4/x to the 5th. Then our last one, rewriting, this is just x to the 3/7. Now rewrite your derivative. So here, your coefficient, so it's 3/7 times x to the, you should have for your new exponent, negative 4/7, because again, subtracting 1, that's 3/7 minus 7/7. So there's your negative 4/7. Now when you rewrite this, here, let me extend. When you rewrite this, you end up with, as your derivative, 3/7, and then inside of the 7th root, x to the 4th. So now notice how in these examples, there was no original coefficient. Like we brought down the exponent, that became the coefficient. So what if we already have one? So now let's take a look at these. So that just means then if I'm finding the derivative here, that when we bring down our exponent, we need to make sure to multiply to the coefficient. So if I've got 5 times x to the 3rd, then make sure to bring down and multiply. That is 5 times 3, which is 15. Then still subtract 1 from your exponent, x squared. So this is the derivative, 15x squared. So then here, again, now it's 5, but over x to the 3rd. Rewrite it. This is the same as 5 times x to the -3, right? Because x to the third is in the denominator. Then here we go. We're going to rewrite it. Make sure when you bring down, multiply, because now we already have a coefficient. So 5 times -3 is now -15. And x to the, now again, watch your signs. This is -1, which makes this -4. So when we rewrite this for our derivative of 5 over x to the third, this is -15 over x to the fourth, because again, x is being raised to that negative exponent. So then our last one here, again, rewrite it. So this is the same as 5 times x to the 1/3, because again, x is being raised to the first power inside of our cubed root. Now we can find our derivative. Again, when you bring down, make sure to multiply. 5 times 1/3 is 5/3. Then x to the, again, subtract 1. Well, that's 1/3 minus 3/3, which now gives you -2/3. Now let's rewrite to have our final derivative. So this is 5 over 3, right? 5/3. Then x to the 2/3. But of course, let's rewrite this in radical form. So 5 over 3 inside of our cubed root is x squared. So this is our derivative. So again, make sure to bring down the exponent, multiply your coefficient, and still subtract 1 from your exponent. Go ahead now, pause the video, and try these 2 U-tries on your own. And here we go. So for the first one, you should have gotten 32x to the third. 4 times 8 is 32, and then subtract 1 from your exponent. This is the derivative. So then here, to get your derivative, you should have rewritten this as 6 times x to the -2. So then your final, when you bring this down, is, so our derivative is -12 over x to the third. Because here you bring down, multiply, there's your -12, subtract 1, your exponent is -3. Then here, when you rewrite this, you should have rewritten this as 10 times x to the 1/5. So then your derivative is 2x to the -4/5, which again, rewrite this as, so write this as 2 over, and then x, inside of our fifth root, so x to the fourth inside of your fifth root.